Hello everyone. I want to welcome you back again in my YouTube channel Mausam Science. This channel always delivers informative and educational video related to science or any field where scientific reason are behind that. Okay, so in this video, if you like such type of video related to science, then you may join my channel by clicking a subscribe button which is just below this video. Okay, uh, now as per our today's content, I want to move towards the topic, that is how electricity is produced. Okay, we'll see how electricity is produced. So for this we'll see a hydroelectricity at first, and after that we'll generalize the concept. The concept will be similar for the other form of electricity. So for this we need this type of setup. Okay, it is called a hydropower plant. Then what we'll do, there will be a river. Okay, we need a large source of water, so we can take from a huge river. Okay, not from a small river, where the water flows continuously all over the year. Okay, from the river we'll collect the water through a dam. Okay, or to a dam. Okay, from river, uh, we as we need some amount of water, we'll collect the water in a dam. Okay, dam will be filled with the water. It will be a very large dam. Okay, as it is shown here in the picture. So this is a dam, and from dam, okay, the water is allowed to move to a tunnel. Okay, we call this as a tunnel, or in other word we call it as a penstock also. Okay, penstock or tunnel. So what we'll do, the water will be filled in a dam. Okay, the water will be filled in a dam, and from the lower part of a dam, because liquid pressure will be more in the depth, we know that. Okay, P is equal to HdG. Okay, it is a term. As the height increases, then the liquid pressure also increases. So that's why from a dam, okay, the lower end of a dam will keep a tunnel. Okay, and there will be a door for the opening and closing of this tunnel. Okay, the water will be allowed to flow through the tunnel, and the water goes directly, and it hits a turbine. You can see that this one is a turbine. It will be like a fan like structure. Then what even if the water comes and hits continuously, then the fan starts to rotate. Okay, by the natural source. Okay, by the natural source of water, the fan starts to rotate. So as soon as the fan starts to rotate, then what even it will be connected with a generator. Okay, generator like a device. It is not powered through the petrol or diesel, but it will be powered through this water. Okay, it will be connected with the generator. So up to here, if we are clear, then this generator moves. Okay, then this generator moves. Now we are clear that we have brought a water from a dam, or water from river to a dam. We'll collect the water as we like. Okay, sometime in a rainy season the water will be more. When the water will be more, then what even will bring a limited amount of water only to a dam. So this will be the controller. Okay, we'll control how much water we need, how much water we let it to flow in a river. So what even from dam, water will be allowed to move through a turbine, and turbine rotates, and as soon as the turbine rotates, generator also starts to rotate. And the rest of the water, okay, when the turbine rotates, we don't need the water, we'll let it to flow from down through the river. This is a powerhouse. Okay, this powerhouse will not be tossed with the river water. So what we'll do is we'll understand a simple term, what happens when this generator moves. Okay, for this we need to understand a Faraday's law of electromagnetic induction. Okay, what it states that whenever a conductor is placed in a varying magnetic field, an electromotive force is induced. Now we need to understand what is the varying magnetic field. Okay, um, varying magnetic field means this is a magnet. Suppose this is a magnet, this one is north pole, this one is south pole. Then we know that the magnetic lines of force, okay, will be started from north pole, it goes to south pole. Okay, there will be many numbers of magnetic lines of force from north to south. Then it creates a magnetic field. Okay, it creates a magnetic field. Then as soon as we see a magnet, we can understand that this magnet creates a magnetic field. So after that, um, If we consider, my figure is not so nice, so I hope you will adjust it. Okay, if you'll connect it with the emitter. Okay, here is one load. Okay, then what we'll do, we have this one current carrying conductor. Suppose this is a copper wire. Okay, and it is connected with the emitter, and one load, electric bulb or anything is connected over here. Simple. If we take a magnet, then we know the magnet have its own field. Okay, suppose this is a north pole, this is south pole, the field goes like this. Then as soon as we see here this Faraday's law of electromagnetic induction, whenever a conductor is placed in a varying magnetic field, now how to vary this magnetic field, how to change the magnetic field? Now the magnetic field is same over here. Okay, how to change for the conductor? Now what we'll do, we'll insert this magnet and we'll take out. Okay, insert, take out. Okay, we'll keep it in, we'll take out. That means the, if we keep the magnet inside, then what happen, it will, the magnetic lines of force will pass from north to south like this. Okay, in this manner. So whenever you take out, then what happen, the magnetic lines of force will be outside. That means the magnetic lines of force coming out through this current carrying coil is changing. Okay, I repeat once, whenever you keep this magnet inside, then all the magnetic field, mm, will pass through this, uh, current carrying conductor. Okay, this coil. But as soon as you take out, it will be outside and no any field pass. That means we will change the magnetic field by this way. Whenever we start to change, there is no any external source, then there will be a detection of current in this emitter and the light glows. Okay, I repeat the same. Whenever you change the magnetic field by inserting or taking out in this current carrying conductor, then what happen, electrical current will be induced. This is the simple term. You can define this in this in your own way also, but this is a theory which is given by Faraday's law. Okay, we'll understand in this term. Okay, it is a definition given by Faraday. Okay, electromotive force is induced. Electromotive force means EMF. We call it as a voltage. Okay, I will deal this later. Voltage will be induced and the current flows in this circuit. Okay, now as soon as we see here, this generator will be connected with this type of magnet. Okay, magnet will be there in the generator. Suppose this is a generator, it will be connected with the magnet. Whenever the generator rotates, then this magnet starts to rotate. Then whenever this magnet starts to rotate, there will be this type of conductor, okay, nearby. So the magnetic lines of force will cross through the conductor sometime and it will not cross sometime. So that's why we'll vary the magnetic field. And what happen, the current will be induced over here and this current will be taken to the transformer. Okay, and it will be step up, it will be step up transformer. If the voltage is low, we'll increase the voltage because we need to travel it to the larger distance. When the voltage is high, the current travels for a larger distance, and in our house we'll use a step down transformer. We'll lower the voltage and we'll get a 220 volt. Here we will get a 11,000 volt. Okay, if the voltage is high, it can travel fast. Voltage is pushing from the back for the electron to move in this circuit. Okay, in this line. So that's why this is the thing. Okay, and here this generator will be connected with this coil. This is the core term. Okay, this generator will be connected with this magnet. It will change the magnetic flux or magnetic field. Okay, then what happen, EMF will be induced and electrical current flows in this circuit, and by the same way we will get electricity in our house. Okay, electrical term is very much important. So I want to deal about the other term also. Suppose a windmill. Okay, we have seen a windmill, how this windmill operates. Okay, in a huge, okay, village there will be a windmill. And what happen, if a air comes and hits this windmill, it starts to move. Whenever it starts to move, it will be connected with the micro generator. Okay, as soon as the generator moves, same thing happens, electromagnetic force will be, EMF will be induced. When the EMF will be induced, then what happen, whenever if EMF is induced, then current will be flown. Okay, same thing is there for the windmill. Okay, but we'll study here windmill and we'll study here hydroelectricity, and there are other forms of generating electricity. okay, from a nuclear power plant, okay, nuclear plant, and with the help of coal, okay. For this we'll burn a coal, okay. For this we don't need water, we'll burn a coal, will be born in a factory, and it will be used to heat a water, okay. But not like this, water will flow in a pipe. I may come a video later with this, okay, with how with a coal electricity can be produced. So I want to go here in the little bit term, okay. With the help of coal, we'll heat a coal, we'll burn a coal, and nearby a coal will take a water, will evaporate a water. When the water will be evaporated in a huge manner, it will be able to blow a turbine, because whenever the water gets evaporated at a higher rate, okay, then it will be able to rotate, and same thing happens, and we'll get a electrical current in our home. So this type of electrical current can be produced in a different manner. So this is the common term, okay. In our house we get electricity from a hydropower plant. So by saying this much, I want to end my today's video. So if you like this type of informative video, then please join my channel, like this video, leave a comment, whatever you like, okay, whatever you desire, what type of video you want in your coming life related to science, okay. So I'll be back again with the new video. I hope you will enjoy very much. I hope you to stay fine, stay healthy, and we'll meet again. Okay, signing off today from the Mausam Science. Okay, thank you.